In this video, we're going to talk about the behavior of the limit of sine x over x as x approaching to 0. Let's go! Notice that the function f of x, which is sine x over x, does not exist when x is 0, but does exist for all other values of x. Because f of 0 does not exist, the graph has a hole in y-axis. So here's the graph of the given function. Now observe that if we have a point located from the left side of the origin, which is x equals 0, as it moves forward into this part, the function values approaching to 1. And same reasoning if we consider the right region. As we move forward close enough to 0, the function or the function values gradually approaching to positive 1. So this implies that the limit of this function as x approaches to 0 is equal to 1 as per the graph we had on the previous slide. And as we investigate further its limit in terms of table of values, so let us construct this table of values from the left side of x equals to 0. Notice that as we move forward to 0, the y values approaching to positive 1. And from the right side, as x approaching to 0, the y values also approaching to positive 1. Now let us treat this function in terms of its limit as a theorem labeled as theorem number 13. So this must be equal to 1. Now let us construct its proof that this is just really equal to 1. Okay. So instead of using the variable x, let us use theta, the symbol theta, because for some reason we will emphasize the concept of a unit circle here. So once you have a unit circle, we have angles. That's why it is preferred to use theta instead of variable letter x. So in a unit circle, we all know that this circle has a radius of 1. And let us focus at the quadrant 1. Okay. Given the fact that this circle contains a 1 unit radius, so the measurement from the center to here is 1 unit. That's why the coordinate is 0, 1. And at the same time, from the center to here is 1 unit. That's why the coordinate on this location is 1, 0. Let us put a line segment on this position, and of course, its measurement is also equal to 1 since it represents a radius. Now, once we have a line segment on that location, an angle has been generated and we will denote this as theta. Now, our concern here is to build a three functions that will arrive to the concept of the squeeze theorem. So what are those functions? Let us begin with an arc. This arc has a measurement of r times theta. You can recall your geometry. R times theta. R is a radius. Since this is a unit circle, the value of r is 1. Then theta is unknown, so as is lang natin to. Now simplify, 1 times theta is equal to theta. This implies that the arc length is theta. This is our first function. Next is, let us construct an imaginary vertical line labeled as blue in this manner. Notice that a right triangle has been generated. Our goal is to find the measurement of this vertical line, and let us represent this as variable letter y. Now, to determine the value of y, let us use one of the 6 trigonometric functions, and that is sine theta. Recall from your trigonometry class that sine theta is equal to opposite over hypotenuse. since theta is located here, the opposite side is y. So we have sine theta equals y over hypotenuse. Hypotenuse is 1 unit. So simplifying, we will obtain sine theta is equal to y. Therefore, the value of this vertical blue line is sine theta. So in that case, the second function has been acquired. The only concern now is the third function. So what's the third function? Let us construct a vertical green line on this location. Now, once na nilagay natin siya dyan, observe that we have to extend the length of the hypotenuse part so that we can construct a right triangle. Okay, another right triangle. This is a bigger triangle compared to previous one. So our next mission is to find the length of this vertical green line, and we will denote this as variable y again. Now to determine the desired value, let us use another one of the trigonometric functions, and that is tangent theta. Why tangent? We have to use tangent because its ratio is the opposite side divided by the adjacent side. If this is the theta, the opposite side is y. And the adjacent side is equal to 1 unit. This is 1 unit. So this must be 1. Now, simplifying, we will obtain tangent theta, and y divided by 1 is equal to y. So we can say that the measurement of the line segment y, the green vertical line, is tangent theta. Okay. Now we have the three functions. Now here we can represent the sine theta or the blue vertical line as f. Then the middle curve is your letter g, and the green vertical line represents h. F, G, and H. Are you familiar with these functions? The illustration shows us that the yellow curve appeared from the right side of the vertical blue line, so G is greater than F. On the other hand, the color green vertical line reflected from the right side of the yellow curve, so we can say that H is greater than G. But what is F? F represents sine theta. G represents the yellow arc, which is theta. And H represents the green vertical line, which is tangent theta. Notice that theta is approaching to 0. So if theta approaching to 0, eventually theta will reach 0 itself. So if we try to evaluate or to substitute 0 to theta, we have this: sine 0 degree less than 0 less than tangent 0 degree. Okay. Sine 0 is equal to 0. This is 0. Tangent 0 is 0. So here, these are now equal to each other. So we can say that the inequality will change from less than symbol to less than or equal to. So this inequality will serve as a stepping stone in order for us to arrive on this original function, which is sine theta over theta. Now let's take the reciprocal of each term. The reciprocal of sine theta is 1 over sine theta. Reciprocal of theta is 1 over theta, while the reciprocal of tangent theta is 1 over tangent theta. Now, once we apply the reciprocal form, the inequality sign will change its direction. So, from less than or equal to, it will turn into a greater than or equal to. Now, observe that the 1 over tangent theta is equivalent to cotangent theta by its identity. Now, cotangent theta is also equivalent to cosine over sine theta. Now, our goal is to show this kind of function, sine theta over theta, but on the middle part, we only have 1 over theta. So all we have to do is to multiply sine theta to everybody. So by performing that, sine theta times 1 over sine theta is 1. Sine theta times 1 over theta is sine theta over theta. And lastly, sine theta times cosine theta over sine theta. Sine theta will cancel, so the remaining term is just cosine theta. Observe that the middle function now is in terms of sine theta over theta, which is our original function. So, let us get the limit as theta approaching to 0. The limit of 1 as theta approaching to 0 is 1. The limit of cosine theta as theta approaching to 0 is also 1. Now, let us use the squeeze theorem. By squeeze theorem, if this function is 1, this function is also 1, we can conclude that the limit of sine theta over theta as theta approaching to 0 is 1. So that's all for our video. Thank you so much for listening. Bye-bye.